Okay, so this is a sample of a process flow diagram, right? Or a production process flow chart. And it's very important that we put out these kinds of samples so that we don't just speak. Now, this is a production process flow chart, and you can see we have diagrams and boxes that are indicating the process steps. Not every production flow diagram or process flow diagram will come out like this, right? Some would not have pictures. This has pictures and boxes indicating the steps. There will be process flow diagrams that will just be notations, boxes, diagrams, boxes, diamonds, ellipses to be able to show steps according to the standardized flow, the way flow charts generally tend to be standardized. But of course, it is also clear and it's good and it can be used for what we intend to demonstrate. And this is also for CMAX group and it's publicly available, right? It's available in public domain, right? But it's also very good for this example. It is labeled the production process flow chart. And these are the keys, and I will explain the keys, right, as we proceed, right? But let's deal with the production process steps as outlined in the flow chart, in the process flow chart. Now, you have the production plants and the location. This is the location is written in language that looks interestingly Italian, right? And then this is the revision number, right? Revision 1 on the 30th day of the 7th month of 2019. It's very important also to state that anytime the production plant changes or the production steps change, it's very important that we should update this manual considering the impact of the change on various aspects, whether storage, inspection, material handling, or whatever. We want to make sure that we update this for every change or updates in the manufacturing plant or its process. It's very important that we update these process steps and the process documentation that supports any aspect of the process, right? And we're going to see the aspects of the process naturally spoken about as we go through this sheet. Now, so let's look at the each of the legends. It would not help so much to touch on the legends right here, right? Without going through. So let's look at the steps. Then when we come to where the legends are required, then we'll speak about them. Now, the first step is incoming raw material identification, right? Now, the first step is what? Incoming raw material. We want to identify them, right? Now, incoming raw material can be broken down into homogenization or blending, right? Now, let's look at the meaning of this green point. This green point means controls performed by the laboratory. So meaning that the homogenization or blending should be performed by the laboratory. Let's also look at the meaning of the star and blending. The red star means product sampling point for inspection or audit, right? So meaning this is also a sampling point for inspection or audit, and then magnet or metal detecting point, right? It's also a magnet or metal detecting point, right, for the incoming raw material. So yes, we do the homogenization and blending to be able to audit and detect things, right? Now, still on the incoming raw material, we go into inspection. Note that this green box means that the controls are performed by the laboratory. And then this red, of course, means product sampling point or for inspection or audit, in this case, by the laboratory. So you can see we have an individual here carrying out the inspection. And then incoming raw material storage, again, controls are performed by the laboratory. And you can see we've been able to store it in some form of warehouse, right? Now, we're moving on to the production process, which is setup, pre-mixing of components, right? And then you see the controls, this orange, I think it's orange, controls are performed by production. Setup will include pre-mixing of the components, right? And then of course, setup will include feeders filling, again, controlled by production. And then setup will include extruder setup, which will be screw, cleaning, and setting the process parameters, right? Again, controlled by production. So you can see step 3, which is extrusion, which is feeding, right? Now, these purple controls performed by laboratory and working together with production, right? We have extrusion, degassing, we have extrusion filtering. We have granulation controlled by production and laboratory, cooling, drying, and cutting, right? And then we have granulation, which is what? Sieving, right? Under process steps 4. Now, under process steps 5, so you can see the output, we have lump powder, which will be scraps, and then we have pellets, right? And then we go on to process step 5. Now, before we go into sieving, during granulation, cooling, drying, and cutting, we would have what? Step 5, which is collecting in silos, transfer, and homogenization, right? Then if we go on from step 4 into sieving, then we have pellets, and then we collect in silo with what? Metal detecting. So at this point, we collect in silos, right? Which is step 5. And then, like I said, the red is what? Product sampling point for inspection or audit. And then the green is what? Magnet or metal detection point. And then we proceed on to step 6, which is the management of the finished goods, external silo transport, and storage. This probably is our internal silo. And then we'll have what? External silo transport and storage. Right. Now, for those collected in silo for transfer and homogenization, right, we also have step 6, management of finished good, packaging and labeling. Management of finished good will move to warehouse storage, right? And then, of course, management of finished goods, right, we transport to the customer. Again, from this one, we have what? External silo and storage, right? All goes up to transport to the customer. So this is a whole process step. This has been able to describe very clearly our production processes in a flow chart. Now, this is not the standard flow chart that uses flow chart notation, but this is also very easy to understand and well described so that any person that is working with this process flow chart or process flow system should be able to understand, right, not only the steps, because the steps are properly delineated, but the levels of controls. You can see the green boxes are controls performed by laboratory. Orange boxes are controls performed by laboratory. And then purple boxes are controls performed by both the laboratory and the production. You can see inspection points where we have product sampling point for inspection or audit. For green stars, for red stars, we have magnet or metal detection points, right? Now you can see for the arrows show that we have what? Mechanical transport, right? The blue means that we have what? Pneumatic transport, and then the green means that what? The transportation is through gravity. So you can see this is a clear expression of how work is being performed, and you don't need to be a very fantastic it's not a complicated thing. You don't need to be a brain scientist or a brain surgeon or and you don't need to be a brain surgeon or have extraordinary understanding capabilities to be able to use this. And that's what a process flow chart should be. It should be descriptive, it should be clear, it should be easy to use, should be easy to communicate. And this helps by clearly outlining the process steps, color coding them, and making sure that your color coding and your process steps aligns with the legend that describes each and every element in the process chart, right? And hopefully you'll be able to build this for the manufacturing process. And even if your manufacturing process already has one, you can be able to use it and improve it. And thank you very much for being with us up till this point, and I'll see you in the next video. Bye for now.